So these are the different types of energy, and I'm not going to go into what each one is. I think you might know a lot of it already, but I'm just going to highlight some of the key points that often catch people out. So first of all, let's just what are all these green things? Well, that means we can call them potential energies, and that means it's a type of energy that can be stored. Um, so, for example, elastic energy. If you pull back a spring, then it will store that energy until you release the spring, and then it releases and turns it in this usually into kinetic energy, maybe always into kinetic energy, with elastic energy. So that is what potential energy means: energy that can be stored. Now, if we go from top to bottom, the first thing you'll notice is kinetic energy is apparently a type of potential energy. We often don't think of it as a type of potential energy because if something is moving, it's weird to think of it as being having that energy stored. So the best example I think for thinking about a kinetic energy as a stored energy is imagining a meteor flying through space. As meteors fly through space, they if they don't touch anything, don't come into collision with anything, there's no friction, there's no air resistance, then they'll continue to go at that same speed forever and ever and ever. And so they have that energy stored within them. And as soon as they collide with something, the kinetic energy that they have stored within them will be transferred into heat, sound, and so on. And also give it kinetic energy, something else that it might have hit. So kinetic energy is a stored energy. That's the one thing that gets confusing about kinetic energy. Chemical energy is confusing because, well, people often forget what is chemical energy and they forget to identify when something has kinetic chemical energy. Anything that's a fuel, or well, basically anything that's a fuel really is chemical energy. If you're able to release the energy by using a chemical reaction, then there must have been energy in the first place, and the type of energy that was stored is called chemical energy. So when you set fire to some wood, then you're going to generate heat energy. And where did that heat energy come from? It came from the wood. There was energy trapped inside the bonds within the wood, and so when you burn it, and it you end up reacting it with the carbon, and it produces carbon dioxide and water. Actually, bizarrely enough, then energy is released. I'm oversimplifying it because I'm not teaching chemistry at the moment, but when there's a chemical reaction, well, we know from chemistry there's endothermic and exothermic reactions, and if the reaction is exothermic, energy was released. So beforehand, the reactants must have had some chemical energy within them. So batteries, food, whenever we eat some food, we eat it to gain energy. So again, the food must have had energy inside of it in the first place. Elastic energy, the key thing to notice about elastic energy is that unless the spring is coiled or unless the elastic band is stretched or whatever, anything else, unless something is pulled back and ready to bounce back, then unless that has happened, it doesn't have elastic energy. So a bag of springs bought from the shop, none of them have elastic energy unless you take one out of them and you stretch it. Then that one spring has elastic energy. It only has the springs only have a potential to gain elastic potential energy. They could gain elastic potential energy if I I stretch them. Gravitational. Let's look through here. Thermal energy, electrical energy. Well, thermal energy, if something gives out thermal energy, if something gives out heat, then it's giving out thermal energy. Heat is just another word for thermal energy. Electrical energy is a type of energy that can be transferred along a wire. So it's a good, convenient way of turning, say, chemical energy into light energy. You get the chemical energy from a battery, and that produces an electrical current, which can be thought of as a type of electrical energy that goes along the wire and then produces light energy in a light bulb. Um, Now, you can actually have electrical potential energy, but we don't often think about it in this way. I'll demonstrate how just briefly down here, that you could have electrical potential energy. if you had an object, let's imagine two objects down here, and one of oops, let's try that again. Um, so we can say that this one is positively charged and this one is negatively charged. If I move this negatively charged object away, it will um, it will want to move towards it. So it has potential energy to move towards it. And so in the same way as like a stretched spring or a ball that's about to be dropped down, it has the potential to move back up to it, or the other one move back down to it. Um, so you actually can have like electrical potential energy, but usually we don't think about it in that way. So I've not highlighted it. Gravitational energy, yeah, we know that that has anything that's raised up high enough and anything that's raised up any distance at all will has the potential to fall back down again, and so it has gravitational energy. Now, I think the most important thing to realize about gravitational energy is that we never really think of something as having, or we barely ever think of something as having a particular amount of gravitational energy. We usually think about how much gravitational energy something has lost or gained. And the reason for that, and I'll draw another little diagram here, is let's imagine we have a ball falling from, so we can say, oh, this how much gravitational energy does this ball have? Here's the floor, and we measure the height to be say 1 meter. The we haven't. I'm not going to really focus too much on the formulae for energies at the moment, but let's just briefly do this one. Gravitational energy can be calculated by mass times times the strength of gravity times the height. So if I so you can we'd be able to calculate how much gravitational energy this ball had, um, and but then if it but that's assuming that this point is where when it's at this on this ground, gravitational energy is equal to zero. But if I dug a hole like that, then clearly it would fall down the hole. So it wouldn't be correct to say that it really had zero gravitational energy at that point. Um, so you don't really talk about it as the as the amount of gravitational energy something has. You talk about it as the change in gravitational energy. So how much energy has it lost or gained? Um, what can we say about light energy? Light energy can be redefined as electromagnetic energy. So, because we know that from learning about waves, that light is just one type of electromagnetic wave. So, if something gives out light energy, then it's giving out electromagnetic energy, really. It could be giving out ultraviolet light, it could be giving out infrared light, radio waves, it will still be giving out energy. So we can group all those type of electromagnetic waves into just electromagnetic energy as opposed to just light energy. Sound energy, we can think about it as heat and light. Basically, it's giving something out. It's actually, it could be thought of as, one second. Okay, anyway, so yeah, that's a light. Okay, so sound energy. In fact, sound energy and thermal energy and a few other, maybe just those two actually, can also be thought of as kinetic energy when you look at what's actually happening at the microscopic level. But we don't generally think about that at this stage. We may think about that when you go into A level and you start to realize more clearly what's going on. And so when something is producing sound, what's actually happening is it's vibrating, and these vibrations are causing the air particles around it to vibrate. Those air particles are causing other air particles to vibrate, and this energy is spreads out. So just like heat and light, the energy spreads out and it can't be contained. It's simply it's lost to the surroundings. Okay, so that's all I've said about that one. Nuclear energy, you'll learn more about this when you go to look at nuclear physics or atomic physics. So, for example, in nuclear fission, that's when, in nuclear power stations and nuclear bombs, energy is released in via nuclear reactions. So, it's very similar, certainly within this topic, you can think about it as very similarly to chemical energy. Of course, it's not chemical energy because it's not a chemical reaction, it's a nuclear reaction. But in terms of our understanding of how the energy is released, it can be thought of in a very similar way. Then we've got magnetic energy, and there's not much to say about that, apart from if you think about it, you can have two magnets close to each other, and if you let go, they'll move together. And so the kinetic energy is being generated, which means there must have been energy in the first place, and we can call that magnetic energy. So those are all the different types of energies that, unless I've forgotten any there, those are all the different types, and those are the key things to realize about them. Okay, so now we're going to be looking at how they transfer from one to another, or how the energy changes from one type to another.